Hello, Professor Matthew. This is the final project for the RBT 131 on robotics. I had create the 4-bit adder circuit. I have the picture over here using the AND gates, OR gates, and NOT gates. As you can see, I have three full adders and a half adder. So we got one full adder on this area over here, another full adder over here. The last one will be over here, and this will be the final one, as well as this 4-bit adder. I had create the truth table for a 4-bit adder. Um, this truth table consists of 8 inputs and 5 outputs. Since it's 2 to the 8th, we have 256 possible combinations on a 4-bit adder circuit. Um, I did create every single possible combination that we can possibly get with this circuit, and all the 5 different outputs for the 256 combinations. I was able to do this by doing by analyzing the circuit on my Logisim circuit. This is just the export picture for the real circuit. Um, right here in this file, we have the half adder, which would be this one, and to be able to create the 4-bit adder, we have 4 of these ones, which are a full adder. uh, Consists only in these 2 half adders. So we got 3 full adders and 1 half adder. So for the 4-bit adder, we got 3 fulls, 1 half. Um, so right now we're gonna process some of the outputs to make sure the whole circuit is working fine. We got the Excel file here. We're gonna try doing a random one. We're gonna do number 55. So we got 00110101. We're gonna do it on the Logisim circuit to make sure we get the output that we needed. So we're gonna do 55 0011 101. We're gonna go over here. We got 00110101. So the output we should be getting will be this one if we put the right numbers. 00110101. I'm gonna make sure I got it right. 00110101. We'll check it again. Looks correct. So we got for S0, we got 0, S1 1, S0 and S3 and S3 are 0, and the C out is 0. So we got 0 1 and 3 zeros following on the 5 output results. And again here we got 0 1 0 0 0. It matches. I'm gonna do another demonstration, just making sure that all 5 outputs respond to the circuit. I'm just gonna click randomly just to make sure that every single goes and turn 1. And the last one you can see over here, all turn on. There is no errors around the whole circuit. We have 3 different gates. We got the NOT gate, AND gate, and OR gate. 8 different inputs, 5 different outputs. What I did on my, so when we got on class and we did the 3-bit adder, the only thing I did at a full adder, and the connections I made from A1 AND gate connected to the full adder I have over here, since this one was connected to another input, which is the CIN. So I just did the transformation from number 2 to get it connected here, and for the output number 3, which was the sum output on the full adder, I just added it to the half adder on the second full adder from the 3-bit results. I think that's everything from this final assignment. Just want to double check more numbers to make sure they're all correct. As I said, have the image here and the truth table. 2 to the 8, 256 possible combinations. The best way to do that is I went here, File and Project, Analyze Circuit, and then Computing Truth Table instead of expression due the label. So when you do that, you get the truth table over here when I put it on this image, and you get the whole table already set up for you. And if the truth table was, and if the 4-bit adder circuit was incorrectly settled and the connections I did were wrong, you could see here some errors. So I'm gonna try to do a demonstration. For example, if I take this one off from this circuit over here, so we get an error in here, right? And if I analyze this circuit again and I look at the truth table, I should be able to see that there were defects and I wasn't able to. Let's try it again. Okay, I guess this one, well, when we build, it will just not work because we'll get errors automatically. So let's just add this one again over here. It's working fine. If I delete this one, now you get the error in here that if we analyze the circuit, you see all the errors over here, meaning that the possible combinations that had that input are not able to be 1 or 0 for the output because they're all incorrectly. So all the outputs that have the input on number 3 will be incorrect if the circuit is not wrong. But as soon as I edit, the error is over and the circuit is fine. Once again, I just added my full adder, connected over here, and from the 3 I connected to this one, and all the possible inputs were able to function. And yeah, that's it. I think it was a really nice project. It wasn't that complicated. It was hard doing the truth table from the beginning, trying to figure out all the possible combinations, but it was nice to figure out that in Logisim simulation we were able to project and get the truth table. Another cool thing is with Logisim we can do different simulations and have the same outputs. For example, when we compute this and we build a circuit, Logisim give you the option just to use AND gates or 2 input gates only. We're using 3 different input gates. So we click here and we click yes. What the system does is organize it more technological and just using 2 different gates, which in this case is the OR gate and AND gate. And once again, it inputs 1 output. We got 2, 3, 4, 5. Same thing, but just a different one, and they use all 3 different gates over here. It was pretty neat to see how they set it up, or how organized it is. But this is the one I created, and it works fine. All the 5 outputs work, all the 8 inputs work, no errors whatsoever, and that's it. Once again, it was great having this class. Enjoy it a lot, and hope to use all these circuits for my SIP projects for graduation. Well, it was nice learning all about this. See ya.